Exponential growth and decay, word problems, algebra 2, trigonometry regions. There's two types of formulas we're going to see in this section, and this video is being shot in a logarithm chapter, but we're actually not going to do any logarithms in this video. We're going to do logarithms in the next one. This one is to get you familiar with these formulas so that you can do logarithms with them in the next video. But first, let me just highlight a couple of formulas for you. There's, in number one, this formula here. This is the standard exponential growth and decay formula. Well, actually, it's the formula for growth, not decay. If it were decay, the only difference would be that this plus sign here would actually be a minus sign if it were decay. This one right here. So we're gonna see this formula, and I'm gonna read the question in a minute, and it talks about what all these different things are and so on, for a compound interest and stuff like that. And anyway, so that's one formula, and then the second formula, which is the second example I'm gonna go over, is the PERT formula, the PE to the RT formula. So I'll talk about these two formulas in these videos, and that's what we're gonna practice using is these two formulas. So, all right, so first to number one. The question is read as, switch back to a pen. If $5,000 is invested at a rate of 3% interest compounded quarterly, what is the value of the investment in 5 years? And then use the formula where A is the amount accrued, P is the principal, R is the interest rate, N is the number of times per year the money is compounded, and T is the length of time in years. So this is very standard. So let me, again, kind of reiterate what all this stuff means. A is, they call accrued. You could think of it kind of like the amount in the account. So let's say you have a savings account, you invest 5,000 into it, what's it worth in 5 years? Obviously, if it's a good savings account, your money's going to go up, right? So A is how much money is in the account at a given time. Time is T. So in 5 years, we'll put 5 for T. How much money is in the account is A. P is called the principal. P is the principal. Excuse me. P is the principal investment, and basically it's the initial amount. It's what you start with. So P is the starting value. So in this particular question, now we're solving for A here. They want to know how much is in the account, and we're going to be solving for A in all these problems pretty much in this lesson. We're going to be solving for the exponents in the next lesson. That's why it's a log lesson. But this one, we're basically just going to be plugging numbers in here and letting our calculator get us an answer. That's what this lecture is. So the amount A equals your principal, your starting value, and the problem tells us that $5,000 is invested. So that is P. 1 plus. Now, as I mentioned earlier, there's a plus sign here because we're hoping our savings account is going to gain interest. It's going to gain money, not lose it. If we were, so it's an exponential growth model. If we were losing money, sometimes those problems are, there's a population of, some type of fish in the sea, and the population is getting smaller. By this formula, you'll see a minus there. So if things are getting smaller, if it's decaying. R is your interest rate, and they tell us that the rate is 3%, but we don't put a 3 because 3% is a decimal of 0.03. And what you could do is basically, if you're not sure how to convert 3% to 0.03, it's how much out of 100th in terms of a decimal goes. So the easiest way to do that is if you take this number and you divide this number by 100, you get the 0.03. So whatever your rate is as a percentage, if you divide it by 100, it will give you the decimal rate that we need for the formula R. Now, as I mentioned, T is time. The one thing that really you have to pay attention to for these problems is the N. And they tell us N is the number of times per year the money is compounded. And so this is a compounded interest problem. And it says interest is compounded quarterly. Now, there's There's only a handful of different types of compounded interest we're going to learn about. We're going to learn about compounded annually. So compounded annually means once per year. If you're compounded annually, then basically this equals 1, and you don't really need the 0.03 over 1. You could just do 0.03. So compounded annually is the easiest. That's when it's just a 1 here and here and doesn't really do much. Compounded biannually, the prefix bi means 2. So biannually, twice a year, we'd put a value of 2 for the ends. Then there's compounded quarterly. Quarterly makes you think of quarter or a fourth, but quarterly means 4 times per year, times per year. So because we're doing quarterly in this problem, n equals 4. And that's what we're going to use for our value of n, because 4 times per year our account is going to be compounded with interest. And then t is time, and they're telling us 5 years for time. So annually, n is 1. Biannually is twice a year. Quarterly is 4 times a year. And then there's monthly. Monthly is 12 times per year. And then there's a special type of compounded called compound continuously. And for compound continuously, we use the PE to the RT formula. But first, let's stick with this. So now I just need to evaluate this thing here. And you're going to just type it into your calculator. I would kind of do this in pieces. First, I would keep this number outside, figure out my exponent here is 20 from the 4 times 5. And I'm going to let my calculator do the algebra inside of the parentheses. So that would be 1 plus, and then I'm going to do it in parentheses just to make sure I don't mess anything up here. So 0.03 divided by 4, and 1 plus that gives me 1.0075. So that's the number I'm going to put in here, 1.0075. And now this is 5,000 times this amount, and it's also being raised by the 20. And we do exponents first. So I could just type this whole thing into my calculator now. That wouldn't be too bad. But with this number in here, I'm going to first raise it to the 20th. So exponent first, get that. And then the last thing I do is times the principal starting value, 5,000. And this is the amount of money in my account after 5 years. It's 5805, and it's not a surprise for money. We're rounding to the nearest hundredth like we normally do in society. So 5805.92 is my final answer here, 5805.92. So that's how these problems will go. They're going to give you a investing or starting value P. The 1 is always 1. The plus is always plus unless it's a minus for decay, but it'll be plus or minus. R is your rate, but make sure you don't put your percentage. It's your percentage divided by 100 to make it a decimal. And then N, it could be 1 for annually, 2 for biannually, 4 for quarterly, 12 for monthly, and T is how many years time. So that's how that's going to work. This next question, the formula for continuously compounded interest is A equals PE to the RT. Now that E is the number E that we've seen a couple of times now. It's like 2 point something. I forget what exactly that is. Just want to pull it up in my calculator real quick. That would be, where's the E? Second division sign is E. It's 2.718, so on and so on. And this is where it really becomes useful, is in compound interest questions. So there's actually a little bit less going on here. There's no 1 plus anything like that. But P is still your initial investment, your starting value. R is your rate, and T is your time. So using this formula to the nearest dollar, so that's like a whole number, the amount in the account for 8 years with a $750 investment at 3%. So I'm starting with 750. E is just E. Raised to the R is 3%. Again, as a decimal, though, that's 0.03. So 0.03. And T, time, is 8 years. And this, I am going to just type in exactly as you see it. 750 times E raised to the 0.03 times 8. And I'm going to round this to the nearest dollar. So 953.4 to the nearest dollar is 953. So this is a very heavy calculator topic. The setup is really what you need to remember, and then how to type it in properly. But that's about it.